Welcome back. We're going to talk more about solving equations. We're going to use some of our simplifying strategies, substitution, factoring. For these following examples, we're only going to find solutions within one rotation of the unit circle, so from 0 to 2 pi. So here we are, we're faced with a problem. We've got cosine of 2 theta minus sine of theta equals 1. We need to solve, which means we need to isolate this variable theta. The issue is we have 2 thetas, literally 3 thetas, but we need to be able to get these thetas by themselves. So something that makes this hard to deal with is the fact that we have both a sine and a cosine. One thing we'll do will be to use an angle substitution. I have several cosine double angles. Cosine 2 theta, we know, is cosine squared theta minus sine squared theta. We also know we have 1 minus 2 sine squared theta, or we could use 2 cosine squared theta minus 1. So I have 3 substitutions, and the reason I'm choosing to make this substitution is because I have a double angle here. I need to get rid of that double angle. Now, 2 of my choices have a cosine, and all of them would give me the correct answer, but some of them may take, more steps than we likely need. So when I look at my function, I say, well, I already have a sine in here. And because this top one and this bottom one have cosines, I'm going to choose to sub in 1 minus 2 sine squared theta. And when I do that, I have 1 minus 2 sine squared theta minus, and I'll leave this in the other color because we already had this, minus sine theta equals 1. So I'm starting to say, well, this might be simpler. One thing I could do would be subtract 1 from both sides. Also, I have a squared term, a linear term to the first power, and a constant term, sine to the 0th power. So I might start to recognize this quadratic patterning, ax squared plus bx plus c equals 0. And when I have them in that quadratic form, we might try to factor a GCF, factor by the AC method, or guess and check. And if it's not factorable, we can always use the quadratic formula, which eventually we'll see. All right, so I'm going to start simplifying. I'm going to subtract 1 from both sides. Now I have negative 2 sine squared theta minus sine theta equals 0. And at this point, I notice that I have 2 terms and both of them have a sine theta. So I'm going to factor a GCF. And actually, since they're both negative, I'm going to factor out negative sine theta. That leaves me with 2 sine theta plus 1 equals 0. Because I factored that negative out, this becomes positive. And if you're unsure about your GCF, you could always, multiply it back through, make sure you have the original statement. So now I have 2 factors equal to 0. I started with a double angle, I turned it into something that was quadratic, and now I have 2 linear factors. So by the 0 product principle, I can take each of these factors, I can say sine theta, negative sine theta equals 0, as well as 2 sine theta plus 1 equals 0. So I'm going to solve each of these equations. This is sine theta equals 0. The other one, I'll subtract 1 and divide by 2. I have sine theta equals negative 1/2. So now I need to determine where on the unit circle are these thetas that will satisfy the equations. And sine, the y value, those ordered pairs being equal to 0, that's going to occur at 0 or 2 pi. We've got 1, 0, and at pi we have -1, 0. So I've got 0 and pi or 2 pi. Now, while we're on this topic, am I allowed to include 2 pi? And because we have that parenthesis, no. So we're just going to say 0. So for this first half, we have theta equals 0 and pi. And then for our second half, where on the unit circle is sine equal to 1/2, where is sine negative? So we end up with, at pi over 6, we know we have the ordered pair, √3/2, positive 1/2. So I know it's going to be at one of these symmetric pi over 6 angles. Of course, sine needs to be negative. So I'm going to go down to quadrant 3. That would be 7 pi over 6. And quadrant 4, 11 pi over 6. So I have 7 pi over 6 and 11 pi over 6. And now these 4 values all represent my solutions. If we think about checking this, right? You guys have your graphing calculators. I want you to feel comfortable using them and checking them. All you have to do is plug 0 and 0 in, you'll get 1. What was the other value? We got pi, plug pi and pi. So cosine of 2 pi minus sine of pi equals 1, etc. So you can check it that way. And you should always check your answers to make sure that they are true and they all work in the original problem, as well as they are not extraneous. Now, when we think about the domain of cosine 2 theta and sine 2 theta, it's all real numbers, so there's no restriction. But when we get into secant, tangent, cotangent, and cosecant, those have vertical asymptotes. They have undefined input values. All right, so that's how we solve this problem, and we get 4 solutions as our answer. That's it for this video.